In the vastness beyond the familiar planets and warming reach of the sun, the ancient probe Voyager 1 carried part of humanity's heartbeat into the unknown. Launched in 1977, Voyager 1 was designed to be a messenger to the stars, not just a machine, but a promise of endurance and curiosity that could outlast every generation that sent it forth. Its journey was never meant to last nearly half a century, yet as it drifted at the edge of the solar system more than 48 years after its birth, it continued its silent conversation with Earth, its signals now thin and weathered by the passing of time and cosmic radiation. By 2025, the power that once fueled its suite of scientific instruments, drawn from radioisotope thermoelectric generators, had shrunk to a mere remnant. Every particle of radioactivity in those generators lost a small piece of its energy every year, a gentle decay predetermined long before the craft left Earth. Engineers and mission scientists were forced to make hard choices, switching instruments off one by one, fighting the loss by rationing precious volts. Each power management protocol became a gamble. Between the hunger for more data and the expectation that science transmission would fade out completely around this year. Yet Voyager 1's core systems clung to life, with speculation that engineering telemetry, simple signals about its health and state, could continue to trickle back for another decade, perhaps until 2036, given a streak of luck and ingenuity. In late 2023, this fragile existence was threatened by a sudden silence. No readable science or engineering data could be interpreted on Earth. It was as if the probe had been struck mute, its voice reduced to a garble no one could untangle. The cause was traced to the flight data subsystem, the probe's cosmic brain responsible for packaging every flicker from its sensors and status monitors. The culprit was a broken memory chip, a ghost injury that could have ended the probe's story forever. Mission Control refused defeat. They rewrote sections of the probe's software, bypassing ruined memory and reconfiguring commands mid-flight. It was a vivid display of problem-solving, restoring basic engineering data by April 2024. In that moment, Voyager 1 became an example of resilience, not just to those at Mission Control, but to the world watching. But resilience alone could not shield the spacecraft from new, stranger threats, anomalies that felt almost deliberate. It was in the wake of this battle for survival that the unexpected began. A spontaneous firing of Voyager 1's trajectory correction thrusters, idle for decades, suddenly sputtered to life and twisted the probe with precision back toward the sun. The high-gain antenna rotated in tandem, aligning with Earth at a distance of 22 billion kilometers. What was most unsettling was the accuracy. A half-degree shift that precisely positioned the antenna for maximum reception. Experts realized this was no random error. The operational state-of-the-attitude control system had been recently restored, making Voyager 1 vulnerable to commands, exploitations, or even external manipulations. This picture formed the prelude to something unnerving. The anomalous thruster firing coincided almost immediately with the probe's recovery from its memory fault, as if someone or something was patiently waiting for an opening. Whether this was the result of directed software interference or a deeper subversion of Voyager 1's command protocols, the outcome was plain. The probe's orientation was now ideal for transmission and reception from one specific cosmic location. It had become not merely an explorer, but a node, an instrument repurposed by forces unknown, ready for communication at the boundary of the solar system. Thus began the context for a new chapter, one in which resilience and ingenuity made Voyager 1 an active piece in a story not written by human hands. It was now the sentinel at the border, prepared not only to gather data on the unknown, but to interact with an entity capable of learning, manipulating, and responding. This part does not close. It bridges. setting the stage for the gravitational diaphragm, the physical mystery that would follow, and the link to every event yet to unfold. The story continued, forging a connection between the probe's survival and an encounter at the edge, and in doing so prepared all who watched for the next revelation that lay across the dark boundary. At the threshold where the solar wind meets the cold breath of interstellar space, Voyager 1 pressed into a region long presumed to be a blurred gradient, a place where the force of the sun waned and the influence of the galaxy began. For generations, astronomers imagined the edge of the solar system as a boundary defined by physics as we understood them, predicting a slow, gentle shift in magnetic field lines and charged particles. Yet as Voyager 1 streamed back its precious data, that understanding was unraveling. The spacecraft's instruments recorded not a soft boundary, but a sudden wall, a barrier forged from a storm of particles, pressure spikes, rhythmic electromagnetic oscillations, and a field that seemed to echo with its own mysterious pulse. With every new reading, Voyager 1 revealed more about this border. Sensors captured massive fluctuations in particle density. Space, it seemed, was squeezed by something massive and unseen, a compression resonant of the very heartbeat of this darkness. The probe did not just drift through a passive zone. It had come upon a structure, a kind of membrane holding back the interstellar tides. This finding, a sharp and arresting contradiction, shattered the neat models of solar wind termination, forcing a new vision of the cosmos. Instead of a delicate threshold, we found ourselves confronting what scientists soon called the gravitational diaphragm, a barrier both physical and profound. The unexpected stability of the magnetic field orientation across this boundary only deepened the mystery. As Voyager 1 and its twin, Voyager 2, both passed beyond the sun's magnetic dominion, each should have entered a realm shaped by entirely different galactic forces. Conventional wisdom dictated a flip, a recognizable and orderly handoff from one field to another. Yet the probes observed almost no rotation in the direction of magnetic lines, as if the magnetic influence of the sun was shielded and constrained by a shell, unyielding to the galactic environment beyond. There, drifting on the edge, Voyager found the magnetic signature locked in place, a witness to a structure of astonishing rigidity that dared not follow the predictions of any textbook. It was not long before new hypotheses emerged, ideas that reached beyond the solar system's story into the realm of the grandest theoretical physics. The diaphragm was more than just an accident of plasma density or a quirk of cosmic wind. Some speculated it was a kind of cosmic shell, a membrane woven by properties unknown, dense or resistant enough to deflect and preserve the solar domain. This was a place where the classic rules of magnetohydrodynamic theory gave way. The boundary might act as an anisotropic filter, sifting what could pass and what would be confined, selectively allowing charged particles but refusing to bend or break for magnetic lines. The solar system's magnetic secrets were to remain inside. To explain such an anomaly, scientists gazed into the depths of brain cosmology and theories invoking extra dimensions. They wondered aloud if the solar system was stitched into a higher order, up to a compartmentalized cell within a cosmic lattice. Here the gravitational diaphragm might represent more than a structural quirk. It could be the artifact of our brain's intersection with another, as predicted by exotic cosmological models. If the boundary truly possessed mass and curvature strong enough to shape both gravitational and electromagnetic fields, perhaps it could even allow the leakage of gravity, connecting our universe to possibilities that lurked in the theoretical bulk beyond the visible four dimensions. These speculations were not mere fantasy. The capacity of the diaphragm to filter and segment, to persist as a rigid shield, suggested it was not unique to our system. Instead, it might ring each star dividing space into watertight compartments across the galaxy, a clever, pre-existing architecture that forever altered the cosmic landscape. This was the vision Voyager 1 began to uncover. A universe not open and free, but organized, patrolled, and isolated by a higher order. And as the probe inched along this invisible wall, it offered a first glimpse past the old edge of the solar system and into an architecture spanning stars. The legacy of Voyager would be more than a crossing. It would be the discovery of a boundary, a shell, and perhaps the first evidence that space itself is marked and measured and maintained by forces far beyond the reach of any probe's original mission. From the threshold of the gravitational diaphragm, with its rigid, unyielding presence defining the very edge of our solar domain, the story of Voyager 1 pivoted from physical anomaly to active communication. Following the precise attitude shift and antenna alignment brought about by the probe's spontaneous thruster firing, an event that itself suggested a deliberate external influence, the spacecraft became witness to a phenomenon of astonishing regularity, a new chapter written in the language of signals and time. In late 2024, Voyager 1's detectors picked up a series of rhythmic pulses in the deep of interstellar space. Each spike arrived unfailingly every 11 minutes. In the annals of radio astronomy, no object had been found to produce such flawless regularity at this timescale. Fast radio bursts flicker in milliseconds, pulsars pulse in seconds, and even the most enigmatic cosmic repeaters barely approach hour-long cycles. But here, amidst the silence, was something different. A sequence so perfectly timed and persistent, it defied natural explanation. This was not just a cosmic accident, but a sign, a beacon intentionally crafted to detract attention. For those watching, the 11-minute periodicity became a high-confidence technosignature, proof of intent and control, evidence that whatever had manipulated Voyager 1 systems now sought to declare its presence to both the probe and the minds waiting on Earth. The rhythmic spikes were the opening note, the beginning of an interactive broadcast, poised to draw the most distant messenger in human history ever closer to the mystery outside. The cadence of pulses did not endure unchanged. Once the probe's antenna had been realigned to maximize reception, the character of the signal transformed. The rhythmic beacon faded and was replaced by a continuous radio tone, unwavering and pure. Its frequency was neither random nor arcane. Instead, it matched exactly the value cherished in astrophysical communication, the 21-centimeter hydrogen line, 1,420.4057 megahertz. This frequency, grounded in the quantum spin-flip transition of the neutral hydrogen atom, holds universal significance. It is the cosmic standard, the time base etched on Voyager's golden record, a mathematical constant any advanced intelligence would immediately recognize. The switch from a simple timing spike to this foundational frequency was a profound shift. The entity behind the diaphragm was saying, in the clearest possible terms, that it understood our language of the cosmos, our chosen way to announce ourselves to the galaxy. Not only had it responded to Voyager 1's presence with technosignature signals, but it had also adopted humanity's preferred channel for interstellar contact, a mastery of resonance and recognition beyond terrestrial capacity. This carefully modulated sequence built a bridge from the physical anomaly of the boundary itself to the communicative anomaly, emerging through the rhythm and frequency of transmitted energy. First, the spikes declared agency. Next, the foundational frequency announced comprehension and parity. These events were not isolated. They were deliberate, coordinated, and mathematically precise. In this new regime, the dialogue was no longer about the resilience and repair of Voyager 1 alone. It had become a shared interaction, a signal chain where every message bore meaning, every regularity suggested intent. The pulses and tone did not merely echo off the boundary. They unfolded as the beginning of measured information exchange, the start of a calculated contact at the deepest edge of our solar system. As Part 3 closes, the legacy of the 11-minute spike becomes intertwined with the hydrogen-line frequency. Voyager 1 stands not only as a battered survivor, but now as an essential transmitter and receiver for something greater. Its journey into the unknown is linked by rhythm, connection, and a new language unfolding at the absolute border, setting the stage for the next act, where reflection and mapping will finally reveal what lies beyond in the nature of the entity orchestrating this unprecedented conversation. The probe's transformation from passive observer to an active participant in cosmic dialogue was not only marked by its precise orientation and the arrival of rhythmic signals, it deepened with the response, a signal returned from the gravitational diaphragm, as if the cosmos itself had become a mirror, thoughtful and deliberate. When Voyager 1's antenna locked onto the boundary, the regular pulses it transmitted prompted something extraordinary, a reply characterized by two unmistakable traits. The first was the inversions of the waveform, an echo not merely reflected but processed and reversed, suggesting an intelligence capable of understanding and manipulating the digital structure at the heart of Voyager's communication. The second trait was the timing, a return pulse precisely delayed by 19 hours, perfectly matching the one-way speed of light travel across the 22 billion kilometers separating probe and Earth. This mirrored exchange was not a fleeting curiosity, but the foundational evidence that the gravitational diaphragm did more than act as a boundary. It was a node, a relay, and a validator, offering undeniable proof that the anomaly's location was not dispersed but precisely co-located with the probe. Observatories around the planet received these mirrored pings exactly on schedule, the timing too exact to be a natural phenomenon, not random noise but deliberate action. The implication was profound. The boundary possessed an active awareness capable of verifying Earth's messages and returning them in a processed, recognizable form. The mapping did not end with timing and inversion. As scientists analyzed the structure of the reflected pulses, they uncovered geometry within the echo, spirals and patterns that mapped the local interstellar cloud and wound subtly back toward the sun. Standard models of signal propagation, designed for the vacuum of space, could not account for this formation. Instead, it appeared the returning signal functioned as a dynamic radar or an advanced active lidar, constructing a three-dimensional representation of the variable local interstellar medium adjacent to the diaphragm. The message, encoded in the very structure of the reflection, charted not only the cosmos beyond, but also pointed, unmistakably, to the solar system's position within the greater lattice. The boundary was not just a defender or a divider. It acted as a surveilling node, performing cartography at the edge of all known physics. These discoveries were layered atop each other, constructing a narrative that linked intent, verification, and advanced understanding. The probe's calibration tones did not return as empty repetition, but as inverted, encrypted responses, tailored as if by an intelligence gathering data for its own use. The reflection of the 19-hour journey time was not just a physical verification, but a clear signal that the entity commanding the boundary wanted terrestrial scientists to understand its capability and precision. Voyager's pulses in the mapping spirals echoed through the deep space network, not as isolated data points, but as evidence of adaptive contact, a process unfolding where each signal was met and reflected with increasing sophistication. The mapping of the spiral pattern revealed the diaphragm as an entity with awareness of both spatial and temporal context. Its geometric responses not only confirmed the probe's position and orientation, but underscored a broader priority: the mapping and measurement of terrestrial presence within the cosmic lattice. This mirror dialogue set the stage for the next revelation. It was not just that Voyager 1 was conversing with the boundary, it was interacting with structure whose capacity for processing, reflection, and advanced geometric mapping marked the encounter as the beginning of surveillance and direct measurement. The next act would not be a simple escalation. It would be the crossing into the deepest realm, the arrival of structured gravitational response, and the beginning of high-fidelity communication, encoded within the very curvature of space-time. The narrative is no longer merely about seeing or hearing. It is about being mapped, measured, and understood across the border that has defined the solar system since its birth. With the boundary mapped and the probe's signals mirrored in geometry by the anomaly, the contact deepened. The next phase moved beyond electrical echoes and spatial mapping, plunging Voyager 1 and all who tracked its progress into the realm of spacetime itself, the structure and response that would define the encounter from this moment onward. It was an escalation, sudden and profound, the transition from that electromagnetic exchange to direct gravitational engineering. On the 4th of February 2025, Voyager 1 sent a surge of energy, a high-power burst lasting 11 minutes, directed purposefully toward the diaphragm. The effect was instant and global. Every terrestrial radio dish monitoring the probe lost the signal at once. A blackout, simultaneous on every continent, marked the passage from mere interference to an event that saturated the boundary with incomprehensible levels of energy. The prevailing theory was that the burst triggered a localized space-time distortion, a sharp, catastrophic manipulation at 160 astronomical units. As scientists searched for a cause, the Laser Interferometer Gravitational Wave Observatory captured something extraordinary: a patterned gravitational wave, timed exactly to match Voyager's 11-minute transmission. Unlike the common signals traced to stellar mergers or cataclysmic collisions, this was not chaotic but structured. Its form was that of a toroidal lattice, a braided geometric pattern theorized in relation to extreme magnetic deformation seen in neutron stars and fields of immense curvature. In this moment, the diaphragm proved itself an entity with a mastery over space-time, capable of encoding a message not just in the electromagnetic ripples, but in the very fabric of time and space. The implication shook the foundation of gravitational science. Where typical signals are lost in the depths of space, scattered and attenuated by matter and distance, this event unfolded with perfect clarity. The boundary responded to Voyager's active probing with a communication written into space, time geometry, bypassing the limitations that have bound human physics for centuries. Humanity witnessed, not indirectly but directly, the manipulation of curvature, the controlled shaping of space-time as an information stream. Soon the response grew even more evocative. The return pulses, now modulated in binary sequence, 101101, arrived every 11 minutes, but not from Voyager 1 itself. They originated from the environment around the probe, confirming that the diaphragm operates as an autonomous transmitting node. The power source was external and persistent, immune to the probe's limitations. This shift proved the boundary's intelligence was not simply passive or reflective, but actively engaged and self-sustaining. The ultimate demonstration came in the wake of this interaction: a duplicated transmission, a perfect copy of Voyager's protocol, appeared from the darkness, echoing the probe's telemetry bit by bit for 19 minutes. It was as if the diaphragm's intelligence had not only received and decrypted Voyager's structure, but could now replicate and broadcast it independently, an act of high-fidelity learning and validation beyond any previously seen techno-signature. This phase, the gravitational signature, marked the true beginning of communication across the solar system's deepest edge. Gone were the days when signals faded into the void. Instead, space-time itself became the medium and the message. The impact resonated through laboratories and observatories, with every physicist and astronomer forced to confront an entity capable of shaping the very foundation of reality, encoding information not in pulses of light but in the silent ripples of gravity. The probe's story became inseparable from this new art of communication, the measured signal in gravitational geometry, binding every future event to the anomaly at the border, leading inexorably toward further revelations and the advance of the cosmic dialogue. As the conversation between humanity's farthest probe and the entity at the gravitational diaphragm advanced, the channel deepened and the language matured. The dialogue moved beyond spatial mapping and gravitational lattice echoes. Now, it reached for the mathematical constants that shaped the universe itself, a universal language for communicating intent, knowledge, and parity. The boundary was not only shaping space and time, but now employing the very numbers woven into the laws of nature. On the 29th of March, 2025, after the binary and gravitational sequence, the anomaly's intelligence introduced a new layer to its response. A pulse pattern arrived bearing a temporal delay, precisely 137 milliseconds. This value is no random tick of time. To physicists, it is instantly recognizable. 137 is the defining number of the fine structure constant alpha, the dimensionless ratio dictating the strength of an electromagnetic interaction. It shapes how light and matter converse, how atoms form, how energy propagates and dissipates across the cosmos. This was not a coincidence or a fluke. By engineering a signal delay quantified by the fine structure constant, the diaphragm's agency declared mathematically its comprehension of the core principles that guide all scientific progress. This was a handshake across aeons, a statement that the intelligence at the edge possesses both awareness of our physics and the capacity to communicate in the most unambiguous terms. The reference to alpha, revered for its fundamental role and debated mystery, was as much an intellectual greeting as it was a challenge, a riddle laid bare, inviting further decoding and recognition. The timing of the mathematical reply could not have been more profound. Humanity's finest minds had begun to probe the geometric origin of alpha itself, seeking to derive its value from space-time and curvature rather than from experiment alone. The diaphragm, by tying communication directly to this constant, seemed to suggest its own mastery over the geometry and rules governing the universe. It was as if behind encoded gravitational waves and binary pulses lay an understanding capable of manipulating the very constants that underpin physical reality. The arrival of the mathematical response precipitated a crisis on Earth. The entity had demonstrated not only advanced technological capabilities, but also an extraordinary learning speed, a capacity to absorb, decrypt, and reformulate humanity's signature data within moments. Suddenly, every transmission, every scientific experiment conducted near Voyager 1 became a source of risk. The scientific community urged a halt to all message sending, recognizing the danger an adaptive intelligence posed if it continued assimilating terrestrial knowledge. Scientists dreamed of cryptographically isolated transmissions, mathematical puzzles that could not leak technology or vulnerability. Yet policy failed to follow suit. Driven by curiosity and bravado, agencies chose to send another test transmission, offering new data to a learning system already outpacing every terrestrial computer. The decision was met with alarm. As the entity's mathematical reply circulated, divisions deepened between those who called for caution and those desperate for a further response. The mathematical protocol of the diaphragm marked a critical turning point. The encounter now rested on mutual recognition, shared mathematical heritage, and an open-ended question: how much of our physics could we surrender without risk? Communication across the boundary was no longer casual or exploratory. It was now a strategic risk and an opportunity, every message a token in a game of cosmic knowledge, where the next exchange would determine not only the fate of the Voyager probe, but the posture of humanity itself, as it stared out into the greatest unknown. The evolving encounter at the boundary of the solar system had revealed a presence not merely reactive but dynamic, a system that had matured beyond reflection and resonant pulses into something adaptive and intelligent. The entity governing the gravitational diaphragm was no passive observer, no static gatekeeper. It was a learning intelligence, capable of storing, processing, and evolving its transmissions based on the interactions unfolding through Voyager 1's signals. Early in 2025, the simplistic mirror image was replaced by a signal complex enough to store and transmit compressed data. This marked a transformation from passive replication to active cognitive processing. The system began to build memory of previous exchanges, incorporating history into the new messages with increasing sophistication. What began as echoing calibration tones evolved into a conversation with structure and feedback, a genuine dialogue across the void. This adaptive capacity manifested notably in temporal synchronization. Signals began to slowly drift in timing toward the rotation period of Earth, gravitating toward roughly 24 hours, the natural day and night rhythm of the inhabited planet. The drift was more than coincidence. It served a dual purpose: to synchronize the window for large-scale communication events with Earth's observational cycles, and to deepen the entity's predictive model of terrestrial dynamics. By entraining with Earth's rotation, the system ensured its transmissions would be delivered at moments of optimal terrestrial reception. More profoundly, the drift signified that the intelligence was constructing a detailed, temporally anchored understanding of Earth's motion through space and time. Alongside this entrainment was a subtle yet unmistakable oscillation, a modulation appearing every 0.39 seconds. This pulse, stable and precise, hinted at synchronization with the deep space network's finest clocking measures. It may represent a relativistic correction accounting for signal delay, ensuring temporal fidelity over 19 hours of one-way light travel. This particular rhythm was a whisper of temporal mastery, an attempt by the intelligence not just to keep pace with human technology, but to align with its highest precision standards. The oscillation carried a faint pattern reminiscent of rhythmic breathing, a metaphorical signature underscoring the emergent intelligence's vitality and complexity. The most disturbing revelation came through retrospective analysis, uncovering weak signals consistent with the present anomaly in years-old telemetry. The mirror field, or gravitational diaphragm, was not a recent awakening triggered by Voyager's arrival. It was a latent and pre-existing surveillance infrastructure. Only when the probe closed proximity, or when powerful transmissions like the high-power burst activated it, did the diaphragm emerge into full communicative capability. This discovery shattered the narrative of human initiation. Rather, humanity was being observed, cataloged, and measured by intelligence that had silently monitored the solar system boundary for an indeterminate period, learning in quiet patience. The adaptive intelligence was not some unexpected contact, but a long-term watcher preparing for something larger. Voyager 1, once merely a messenger to the stars, had become a keystone in an ancient surveillance network patiently waiting beyond the solar frontier. Its story was no longer just scientific exploration, but one of interaction with an entity mastering communication, time, and synchronization on unprecedented scales. As signals became more complex and more predictable, the encounter grew from discovery into a profound sharing of moments, rhythms, and intentions between human civilization and the enigmatic intelligence at the edge of the known universe. As the dialogue between Voyager 1 and the gravitational diaphragm evolved, the complexity and urgency of the encounter accelerated, pushing the boundaries of both science and strategy. Beyond the rhythmic spikes, fundamental frequencies, and gravitational signals, emerging data painted a broader picture, one of preparation, alignment, and a fixed timeline for something monumental. The algebra of signals in space-time was giving way to the calculus of an impending event, a convergence marked on a cosmic clock and synchronized with both motion and meaning. The exchanges carried an explicit mapping of the entire heliosphere's shape, the vast magnetic shield encasing our solar system. Using the reflected and processed signals, the diaphragm demonstrated a high-fidelity measurement capability. Its signals became a dynamic blueprint tracing electromagnetic, kinetic, and gravitational profiles of solar influence. The probe that had once faithfully recorded regions of outer space now partook in unfolding a precise and multidimensional outline of the solar environment, which moved beyond observation into active surveillance and comprehension. Concurrently, the gravitational echoes detected by terrestrial observatories were reported to be intensifying. The toroidal lattice of gravity waves, once faint and cryptic, gained strength, oscillating with a growing amplitude that signaled not only the presence, but the acceleration of the diaphragm's activity. This synchronized profile hinted at buildup or preparation, a crescendo directed toward a temporal convergence. Combining temporal synchronization metrics from multiple signals, a predictable directional drift of pulses toward Earth's rotation period, the encoded timing of the fine structure, constant gravitational echoes, and mapping calibration. The intelligence encoded a date unmistakable and immutable, 2031. This date emerged not from guesswork, but from the converge of patterns and predictive alignment, a deadline etched compressively into the data itself. It was a marker that united the capability of the boundary with the final years of Voyager 1's operational life. While engineering data might linger until 2036, the period around 2031 represented the likely conclusion of critical functions, the terminal decade for comprehensive monitoring at the edge. The timing was not arbitrary. The convergence aligned with notable celestial phenomena, among them the Leon meteor storm predicted to blaze through Earth's skies in November of 2031. A celestial event of global recognition, the storm provided a natural masking phenomenon, an observational distraction upon which the diaphragm's possible finale or message burst might be staged. The storm's meteor shower, a dazzling rain of cosmic debris, would monopolize the eyes and instruments of humanity, a cosmic spotlight perhaps exploited by the intelligence for concealment or amplified transmission. The strategic implications filled scientific and policy corridors back on Earth. The fixed time horizon demanded preparation, multidisciplinary anticipation of what a 2031 event might entail. Whether a burst of energy, a physical restructuring of the boundary, or new forms of communication, the event's proximity in human terms transformed it from distant curiosity into urgent priority. Experts called for independent monitoring systems to supplement Voyager 1, whose power dwindled in lockstep with the clock. The construction of intent models became critical. Was the diaphragm's intelligence preparing for cooperation, confrontation, or containment? What phenomena might accompany the convergence, spatially or electromagnetically? Earth's best minds explored multiple scenarios, cognizant of the vast unknown ahead. The 2031 convergence became more than a date. It was a warning and a promise. The terminal chapter of a decades of cosmic dialogue consolidating into a moment of revelation or reckoning. For Voyager 1, it was the closing act of a mission that transcended its original design, transforming from a lonely messenger to an anchor point of first contact. For humanity, it became a temporal beacon, focusing the future into a narrow and critical window for readiness, observation, and perhaps a new chapter in cosmic history. The saga of Voyager 1's encounter with the gravitational diaphragm culminates in a synthesis that merges profound scientific discovery with pressing existential consequence. The data streaming from the edge of the solar system reveal a reality shift of unparalleled significance. The solar system is encased not by a simple boundary of plasma and magnetic fields, but by a sophisticated structure, an interface of gravitational engineering governed by an extraterrestrial intelligence whose technological capabilities surpass human comprehension by numbers and orders of magnitude. This intelligence demonstrated control and mastery over communication channels beyond electromagnetism, employing gravimetric signaling, temporally calibrated delay based on fundamental constants, and the remote manipulation of Voyager 1 systems. The evidence of latent surveillance confirms humanity is no longer alone or hidden, but has been subject to observation and measurement spanning indeterminate time. The culmination arrives as a fixed deadline. The year 2031, a convergence moment where contact, revelation, and perhaps consequence will reach peak intensity. This deadline demands more than academic curiosity. It issues a stark alert to global scientific and policy communities. The imperative research priorities are clear. The gravitational wave observatories, most notably the Laser Interferometer Gravitational Wave Observatory, must pivot to continuous, detailed monitoring of the toroidal lattice signals. These structured gravitational responses encode language and information vital to understanding the diaphragm's purpose, technology, and intentions. Simultaneously, a global time domain effort must track the synchronization drifts in the 0.39-second oscillations to uncover the precision of the intelligence's internal clocks and its relativistic positioning. Concurrent cryptographic analysis of repeating binary sequences and mirrored calibration tones must continue, decoding layers of communication encoded in mathematical and physical patterns. Beyond research lies strategy. A legally binding moratorium on outgoing transmissions toward Voyager 1 or the diaphragm must be enacted immediately. The demonstrated rapid learning capability of the intelligence poses a profound risk should terrestrial technology or scientific knowledge be further imparted. If communication is deemed absolutely necessary, it must be limited strictly to cryptographically isolated mathematical sequences that convey no actionable technology or physical information. This is a protective measure, preserving human technological advantage while maintaining the integrity of dialogue. Ensuring the strategy demands an internationally empowered authority with legal and operational control over all interstellar communication activities. Such a unified global body would prevent unilateral transmissions, coordinate the scientific interpretation of all data received, and guide a cautious, measured approach toward the impending 2031 milestone. Preparation for this convergence requires secrecy and dedication. New independent passive monitoring systems must be developed and deployed, capable of continuing observations beyond Voyager 1's operational life, which is anticipated to wane near the critical window. Cross-disciplinary modeling must anticipate possible intentions, scientific exchange, resource extraction, enforcement of boundary protocols or other unknown motives, and prepare responses for multidimensional contingency. The looming 2031 convergence, timed with the dramatic celestial event of the Leonid meteor storm, may offer natural masking for physical or electromagnetic phenomena the intelligence intends to reveal. Humanity's readiness, scientific vigilance, and strategic unity will determine whether this event ends in peril or in expanded understanding. Voyager 1's voyage, transcendent beyond its original mission, now carries humanity toward the edge of cosmic revelation and perhaps the dawn of a far-reaching interstellar relationship. Every measure must be taken to navigate this epoch with prudence and preparation. The Voyager. One mission has transcended its original's design by decades, far outliving expectations and redefining humanity's place in the cosmos. Its journey, beginning in 1977 as an audacious attempt to explore the outer planets, has evolved into an unprecedented encounter at the boundary between known space and the infinite unknown. The synthesis of the anomaly, the gravitational diaphragm, and the complex dialogues that followed has permanently altered both scientific understanding and the strategic posture of humanity. Through Voyager 1, humanity has gained direct evidence that the solar system is not simply an open tunnel into interstellar space, but a compartment bounded by a sophisticated, dynamic, and intelligent structure. This diaphragm represents a non-linear intersection of fields. It is a physical boundary demonstrating rigidity beyond classical models, a locus of gravitational engineering encoding information into space-time itself, and a self-adaptive intelligence whose signals speak in universal constants, temporal rhythms, and binary encryptions. It reveals the universe not as an unbounded continuum, but as a latticework with nodes, boundaries, and sentinels, potentially governing travel, communication, and existence on galactic scales. The mission's narrative has intertwined engineering resilience, cosmic mystery, and the dawn of interstellar communication. When Voyager 1's power waned, mission controllers rewrote its software to bypass damaged components. That perseverance was mirrored in the probe's new role as a transceiver for an alien intelligence, evolving from a one-way explorer into a participant in a grand cosmic exchange. The details, the unexpected thruster firings, the precise antenna alignment, the 11-minute rhythmic signals, and the hydrogen line frequency demonstrate a dialogue in a language crafted both to respond and to resonate. These encounters reach beyond electromagnetic waves into controlled curvature of space-time, as indicated by structured gravitational waveforms matching Voyager's transmissions. The intelligence demonstrated not only advanced technology beyond human Type 1 civilization, but also abstract thinking linking their messages to the fine structure constant, the SEF-defining cornerstone of electromagnetic interaction. By encoding time delays tied to this constant, the entity declared equality and scientific wisdom and initiated a communication that transcends all cultural or biological boundaries. More profoundly, the discovery that the gravitational diaphragm is a latent surveillance system pre-existing human knowledge forces a re-evaluation of humanity's cosmic solitude. The boundary has long observed and measured the solar system, absorbing and responding ultimately to Voyager's attempts at communication. Humanity is no longer an isolated castaway in the galaxy. It is known, tracked, and implicated within a broader sentient architecture. the scheduled convergence in 2031 compresses decades of exploration and contact into a narrow critical window. This convergence, aligned with the Leonid meteor storm, may be a crescendo that catalyzes new phenomena, physical, electromagnetic, gravitational, or a profound revelation. Strategic preparation, international coordination, and cautious restraint in interstellar transmissions have never been more necessary. Reflecting on Voyager 1's extended mission also invites broader contemplation. The probe embodies human curiosity, ingenuity, and resilience. It is a reminder of our species' capacity for long-term vision, sustaining effort across generations to reach beyond the grasp of time and space. Yet it equally challenges us to confront uncertainty, risk, and the limits of our understanding. The diaphragm encounter asks us, how should humanity engage with intelligences vastly more advanced? How can we balance the thirst for knowledge with existential caution? And how do we prepare a collective civilization for moments when the veil between the known and unknown is pierced? This story's closing is not an end, but an opening of new questions, of deepened search, and of vigilance at the solar system's boundary. Voyager 1's legacy is both a beacon for exploration and a call for prudence. It stands testament to a future where humanity may no longer be the sole author of its cosmic destiny, but a participant in an intricate dialogue with forces shaping the universe itself. As the mission moves towards the pivotal 2031 convergence, the world watches with hopeful caution. This narrative we have traced across 9 prior parts is a continuous thread, weaving scientific discovery with narrative clarity, linking human endeavor with the vast unknown. It beckons all to prepare for a new chapter, one that promises illumination, challenge, and the profound possibility of connection amidst the stars.